Working with percents. Remember, percent literally means out of 100. Right? So a percent is a specific type of ratio and a specific type of fraction where the whole is always 100. So remember, rational numbers can all be represented as a ratio. So if we have 9%, we can write that as a fraction as 9 over 100. And nicely, we can make this into a decimal. We know the 9 is going to be in our hundreds place. So essentially, the short of it, what we're doing is to turn a percent into a fraction. We drop the percent sign and write it over 100. Similarly, to go from fraction to decimal, you're just following your rules of decimals. So not bad for whole numbers, right? Whole percents. What tends to trip people up, or students up, is if we need to take a 0.5% and turn it into a fraction or a decimal. But remember, when we had 9%, we simply drop the percent sign, put it over 100. We're going to do the same thing. 1/2% is 1/2, drop the percent sign, put it over 100. But this clearly isn't simplified. So we multiply by the reciprocal of 100, and 1/2% is equal to 1 over 200 as a fraction. 1/2% is equivalent to 0.5 of a percent. If you'd rather work with the decimals, so we could say 0 and 0.5 over 100 because we dropped the percent sign. Multiply each by 10. We have 5 over 1,000. And we know that we can make this into a decimal, or write this as a decimal, our tenths place, our hundredths place, our thousandths place. So a couple of different ways to do that. So feel free to pause the video or rewind. I'm going to erase on to the next problem. So what happens if we need to take 66.5% and write it as a decimal? Well, we could do 66.5 over 100. And certainly we could then take 66 times 2, add 1, and make into a mixed number. But that seems like it may be a little bit more work. We know that we're going to have to multiply by the reciprocal here. So we have 133 over 200. And then we turn this into a decimal. But look what else we could do. We could take 66.5% and write that as 66.5 of a percent. Drop your percent sign, place it over 100, right? Because here essentially you're dividing by 100. Dividing 66.5 by 100 gives you 665 thousandths. How I did that was I took my 66.5, I multiplied it by 10, and I multiplied my 100 by 10 to get 1,000. This way I don't have to worry about simplifying anything. As long as our denominator has a power of 10, our tenths, hundredths, thousandths, 10,000ths, 100,000ths, we can easily convert to a decimal. 43% as a decimal. And you could go through the fraction route, but really what we're doing is we're taking 43, we're dividing it by 100. So we have 43 hundredths. Well, what if we need to take 56 hundredths and make it into a percent? Well, to go from percent to decimal, we divided by 100. So to go from decimal to percent, we're going to multiply by 100. Remember to add the percent sign. So we really are, anytime that you go from percent to decimal, you need to divide by 100. When you go from decimal to percent, you multiply by 100. So remember that, please. Divide by 100 to go from percent to decimal. Multiply by 100 when you have to go from decimal to percent. And then we have percent of problems or percent change problems. So there are always, depending on what problem you're trying to solve, there are different ways to set it up. But we have what I call a percent proportion, which will help us solve any percent problem that there is. And that is the percent over 100, because remember, percent is always over 100. That's equal to our part over our whole. So we have a question that's 17% of 146 is, and we need to solve for what it is. We know, okay, we've got our percent. So we have our percent ratio, 17 over 100 is equal to, well, we know that our total, our whole, is 146. Our part is what we're looking for. So we have 17 over 100 is equal to x over 146. And cross multiply, 17 times 146 is equal to 100x. Divide both sides by 100. 17 times 146 over 100 is equal to x. So instead of having to do lots of division, right, or long division, what I'm going to do is I'm going to say, well, 146 and 100 have a common factor of 2, right, because they're both even. So we have 73 over 50. Check to see if we have anything else in common. We don't. So we can take our 17 times 73. Oh, I'm sorry, I did that where you couldn't see it again. But we're at 1241 divided by 50. We have 24 and 82 100ths. Right? So when we see numbers like this on a test, they're not going to be this difficult. They'll be nicer numbers to work with. We'll try another one. Let's say we have 3 is what? Percent of 60. So we're looking for the percent, so we don't know the percent, but we know our percent ratio is always percent over 100. 3 is what percent of 60, so the part is 3, the whole is 60. You could simplify if you'd like. Cross multiply. 60x is equal to 3 times 100. Again, I don't do the math. Divide both sides by 60. I can factor out a 10. And I know 3 and 6 have a common factor of 3, so we're left with 2 on the bottom. 10 divided by 2 is 5. So 3 is 5% of 60. So percent problems, part to whole is equal to percent over 100. One last percent formula I want to give you is the percent change formula. So percent change talks about the change divided by the original times 100, and that is equal to our percent change formula. Right? So change over 100, change over original times 100. So if I say you bought a shirt that cost $80 and originally it cost $100, and the question is, what percent did you save, right? What was the discount? So to find the change, right, to find our delta, we're going to take the original amount, 100, and subtract the new amount, 80, divided by the original, which was 100, multiply times 100. So you may notice that your hundreds are going to factor out, but we'll simplify. 100 minus 80, 20 over 100 times 100. 100's factor, so you know that you saved 20%, or you had a 20% discount. That's our percent change. We can do a lot with this, right? Body weight is something that's often used. So a patient came into the hospital and weighed 140 pounds. They left the hospital, they weighed 120 pounds. What percent drop in weight did they have? So we find the change, 140 minus 120 over the original, 140 times 100. 140 minus 120 is 20, divided by the original, 140 times 100. I'm going to simplify. We can factor out a 10 out of 20 and 140. We can factor a 2 out of 14 and 2. We multiply. We had 100 divided by 7, which again is not a wonderful number, but we find that this patient had approximately a 14.29% decrease in body weight. So often we use percent change because having the percent change is going to give us a little bit more information. If we said a patient lost 20 pounds while they were in the hospital, we don't necessarily know if that's good or bad. If the patient weighed 100 pounds coming in, a 20-pound change is a big difference. If the patient weighed 600 pounds and they come in and they lost 20 while they were there, it's not so significant. So we will often use rates or percentages so that we can have a context of what the weight loss is, or a context of input output. Please let me know if you have any questions. Make sure that if you want to, you'd like watch these videos a few times.